I want to start my talk by asking, why are we here today? Some of you, this is the last talk before the keynote, so some of you must be pretty tired and you are just here because you wanted a place to sit. Maybe some of you actually read the title and were like, oh, this seems interesting, like high performance, that sounds cool. And some of you even saw like DORA metrics and you think it's Dora the Explorer, it's like a cartoon. Well, it's okay, it's okay. It's okay because I know why I'm here today. And like, if you were here in the previous presentation from my colleague Adam, all of us in SalPay, we all have dreams. So I'm going to say that I have a dream also. And my dream is that every engineer should work in a team where they feel empowered and happy and where they can go above and beyond. Some people call these teams high-performance teams, a place where engineers feel empowered, happy, and are able to deliver frequently and with quality. So don't worry, today I'm going to take you on a journey to understand how can we reach this, how can we fulfill this dream. A little bit about me. So my name is Catarina. I've been a software engineer at SalPay since last year, so this is actually a very special day for me because it was 1 year ago that I shifted from Nanotech research, that I started my career as a software engineer at SalPay, and that I started to use Go. Some curiosities about me. I just moved to London also, 1.5 months ago, so it's been pretty nice. And I really like dogs, so you can see that's me and my really best friend for 14 years called Rufus. If you want to contact me, you can contact me with, this is my Twitter handle. So yeah, this, probably you were not expecting this, but we are going to talk about nanotech research. So to take you on the journey, let's start from the beginning. As I said, I was not a software engineer. I used to work in nanotechnology. I was a research scientist. And you can see me here wearing like this very funny suit. And I'm wearing these because I was working with macro and nanotechnology, I had to build very, very small things. And to build these things, I had to work inside a clean room. And for those who don't know, a clean room is a facility that filters out even the smallest particles. You need this sterile environment so you can build these very, very small things. So, as you can guess, this is very expensive, very time-consuming, and very stressful to work inside a clean room. So, I loved science, but I didn't love the experience I had as I was a research scientist. My frustration was really high. And for you to understand why, you can see that if I wanted to do one experiment, every equipment that I was using was very expensive, very big, very fancy. So even one experiment would be so expensive. Easily, it could cost around 1,000 pounds, the experiment I was doing one day. I had to fabricate this microchips, so I had to fabricate sensors. Fabricating the sensor inside the clean room would take usually 1 week or even 2 weeks, depending on the complexity. And I also was working with biological experiments, growing cells. And we cannot speed growing cells, so sometimes I would start growing cells and I had to wait 1 whole month to know the result of my experiment. So this was very frustrating for me because I was trying to build something, but sometimes I would have to wait 1 month to know that that thing was not working, or maybe even I made a mistake setting the experiment and I couldn't even read any result from it. So I had huge feedback loops, and these made my frustration so high. I never saw what I was building being actually used. So we are on a journey, right? And I told you I changed careers. So meanwhile, while doing this, I found my passion in software engineering. And I was very lucky to get a job at SalPay. And I say that I was very lucky because they were giving me exactly what I needed, which is at SouthPay, we exist to serve local business. We are building things and we are trying always to give it to them. So they tell us if it's good or not. They tell us what they need. And for me, this was enticing. We listen to them. We work to understand their problems and always put them first. It so happens that we maybe use technology to do this, but our main goal is to help them. We are a pretty recent company, but we are a pan-European business with a global presence. We are more than 10 countries. We have 14 offices, and we have 1,500 sellers or more. And although we are already so big and so recent, we still feel like a really small company, and I love that. So, speaking about the journey, I was doing nanotech research, I got my job, I was super happy, but then, in the first day, I was not happy anymore. Because then I was like, oh my God, look at how many things I have to learn. Getting to know the code base, learning Go, because I didn't know how to code in Go. Kubernetes, what is that? Testing, architecture, good practices. This was like so scary. And my goal is like not to be a great engineer, just a decent one. So I came very frustrated from research experience. And then I was like, when would I be able to make a meaningful contribution? I had to learn a lot. And again, these were very complex systems and very important, moving money from the small business. So I was super scared of doing anything, and I was feeling that my experience would repeat again. Spoiler alert, everything was fine in the end. Maybe I was a bit dramatic. But everything was fine because I had the luck to work in a team where I felt happy, empowered, I was not afraid, and I feel like I could go above and beyond, although I was barely an engineer. And if this rings a bell to you, we are talking about what we were talking before, a high-performance team, a place where engineers feel empowered, happy, and are able to deliver frequently and with quality. But what I loved about this team is not that it was a high-performance team or not. By that time, I didn't even knew what that meant. What I loved about the team is that I was able to experiment cheaply and without fear. This is something I didn't get in my nanotech research. I was afraid of going inside the clean room. So what was the difference? The difference is that my first week that I joined SouthPay, I deployed code to production. Every 2 weeks, we have demos with our stakeholders, and from the beginning, I participated in that. And I had to answer their answers about what was the value we were delivering, and I had to accept their requests and try to work it out what we were building. I had to deal with incidents. Although they were uncommon, they happen. Failure is inevitable. But I never felt stressed about the incidents because the team had everything under control. And honestly, I don't know, I was so afraid to go inside the clean room, which, okay, it has some expensive equipment, but no one dies. But I was not afraid of an incident happening because I knew that I could trust our processes, even though that sometimes an incident happening in our team means that this local business will not receive their money the next day. And this is very impactful for them. So why is it so important to experiment cheaply and without fear? And I believe it's because it answers the most fundamental question of any tech team. Are we building the right thing? Doesn't matter what technology you are using or if it's super cool and complex. you have to be building the right thing. Do you know if you are building the right thing? Can you give me 100% sure of that in your daily job? By experimenting cheaply and without fear, we can change direction quickly. We are able to experiment and learn from real user feedback. That is a huge power this gives to us. But what I'm saying here is not a new discovery that we had at Salpay. One day we woke up and we're like, we have the solution to all our problems. No, it actually, in 2018, the Accelerate book was released. And this book basically tells us how organizations can become high-performant, how their teams can have a high performance in their delivery, and how they can be happy and make profit. And basically, it answers two questions, which is how to measure performance and what practices lead to performance. So they tell us, you want to be performant because of this and that. This is how you measure, and this is how you become one. So it's pretty cool. And again, this is not some software engineer one day decided to write a book about his ideas. And what I love about this, being a scientist, is that this is actually DORA stands for DevOps Research and Assessment Research Program, and it actually represents 7 years of research and data from over 32,000 professionals worldwide. So it's data-driven, it's not someone's opinion. So we had how to measure, right? So the DORA research program set a set of four metrics called the DORA metrics that tell us if we are high performant or not. And you'll see that this makes sense because the first two answer this question: how often can we deliver this? Which means that if we deliver frequently, we have the ability to experiment cheaply and quickly. And the other set answers the question, what is the quality of our work? If the quality is high, our system is stable, and we are able to experiment without fear. Let's now deep dive into each metric. The first set, which basically is a measure of tempo of the team, of speed. We have deployment frequency, the frequency of successful software releases to production. So high-performance teams and organizations have a high deployment frequency. And you might say, it's the same if I deploy every day or if I deploy once a week, the code is the same. And I'm telling you, no, because if you deploy frequently, you have a smaller feedback loop. And remember, I was telling you my story in a research program where I had a huge feedback loop. I can have feedback more than once a day at Salpay. I maybe had feedback about my research experiment in a good day, in a week, in a bad day, in 1 month. Okay, so this is very important to learn from the user, to put the features out there and understand if they are really useful or not, if you are building the right thing. If you want to deploy frequently, you cannot take a long time to make any change. It should be simple and fast to make a change in your system. That's why you have the second metric, lead time for changes, the time taken for committed code to reach production. And again, going back to my lab story, that's why I couldn't deploy frequently, because I was using these expensive machines and I had my biological experiments, and they would take 1 full month. Like if I wanted to make a change, 1 full month to do anything. At Salpay, if we want to make any change in our code, we can have that being live in production in less than 15 minutes. And also, I'm not scared of deploying frequently and every time, every 15 minutes, because I have trust in the things I deployed. But how do I have trust? We go to the other set of metrics that answer, what is the quality of our work? Experimenting without fear. So it doesn't matter that you are shipping features 5 times a day. If they don't bring any value to the user, and if they make more bugs and errors in your system, then they actually do something good to your system. So you also need to make sure that what you are deploying every day and frequently has quality. So you go to the third metric, which is change failure rate, the percentage of changes that were made to a code base that then resulted in any type of production failure. And ideally, you would like that to be less than 15%. So when I was setting my experiments in the lab, I maybe added like a change failure rate of 80%. Everything was so complex and so new that sometimes, even to make experiments, I could only make one valid 20% of the time I would make one valid experiment. The other 80%, I had errors while trying to set up the experiment. How do we keep the change failure rates low at Salpay? It's because, and in our team, it's because we rely on an automated suite of tests every time we deploy to production. If we want to deploy frequently and fast, we cannot count on someone to review our code line by line and so on. We have to rely and be very confident in our suite of automated testings. And of course, we also practice pair programming, which means that we never work alone in any piece of code. And then comes my favorite metric, which I think it's the hardest one to measure. So it's mean time to recovery, the time it takes for a service to bounce back from a failure. And this is my favorite metric because it accepts the most basic thing about humans. Failure will happen. And if your mean time to recovery is more than a day, it's a week, it means that in your team and in your organization, you are not accepting that failure happens. You are not accepting that things can go wrong. By accepting that failure happens, you can draw a plan to bounce back as quickly as possible. You don't try to, oh, I don't want any failure. That's not realistic. You say, failures will happen, but I will have a plan, so I'm not afraid of them. And this is my favorite one, because I keep saying I was afraid to go inside the clean room. I was afraid because the lab where I worked didn't have a plan if anything failed. If I broke one of those expensive machines, I would ruin all my colleagues' work. How can a lab or even a company work like that? How can you, just because you broke something, the rest of the company doesn't work? That's unimaginable. So I never feel stressed in my team. We have incidents, even not yesterday, but before yesterday, we had one, but we were super pragmatic and we solved everything in less than a day. Okay, so I gave you like the lecture on all the metrics, you already know them. But what I want to highlight in this table is that you have these goals if you want to be considered a high performer or an elite performer, but of course, everything is contextual. So I'm giving you the examples of my research time, research experience, and of course, it's very difficult to release features more than once a day in the nanotech research. It's not realistic. But the thing is that maybe some technologies you use also put you in that constraint. But my point is not, okay, let's have all these metrics on green, we score them all and that's fine. That's not the point. The point is that you measure yourself, and if you are not in the elite performance, ask yourself, am I doing everything I can to score well on these metrics, and I'm not scoring is because it's really impossible, or is there places where I can improve? And I can assure you, most of the times you can improve. Okay, So this leads us to the second part of our presentation. Okay, Catarina, you convinced us. DORA metrics are cool. It's not DORA the Explorer. But how can we measure? Can we do something about it? Because it's cool to talk about these things, but then no one ever measures it, right? So what I want to do today is to give you an example on how at Salpay we started to measure the DORA metrics. And I will tell you, in the beginning, it was in a spreadsheet, because we don't like to do anything that is too complex. We just want to start doing it, even if in the beginning, it's not the most beautiful thing you have ever seen in your life. So we have 4 metrics, but for the sake of time, I'll give you an example of what we did in the first 2, deployment frequency and lead time for changes. And I also want to tell you that it's not one recipe that you will take and go to your company and start doing it. It's very contextual with the tooling and the way we work. So I'm going to explain what are our tools and the way we work. But it's the messages, it's not that difficult. And you can go after this talk and start measuring it. Okay, here we go. We are going to see some code. Well, finally. How we work. So in our team, as I mentioned, we do a lot of pair programming. So usually we have 2 to 3 pairs working at the same time. And we also work in truck-based development, which means we don't have feature branches. We commit directly to our trunk or main branch. And this means that if we have 2, 3 pairs committing to the main branch at the same time, we have to have very much confidence in our suite of automated tests. So that's why I wanted to show you our CI/CD pipeline. So usually we start by committing to main, and this will automatically will run our CI pipeline. If the tests pass, then we will have the Docker image and use this to deploy to staging. And then in the staging environment, once it's deployed, we run end-to-end tests. And if this test pass, then we deploy to production, and eventually we'll also have end-to-end tests running in production. So tests are very important to us because it's what gives us confidence to work the way we work. Our tools. So at Salpay, we have an amazing cloud platform team, and they provide a set of tools for our observability, for our monitoring, and so on. And we decided, okay, let's try to use this and start measuring something. So we use Tekton for creating CI/CD systems. We use Prometheus for open source systems monitoring and alerting toolkit. And we have Grafana for visualization and analysis and to have our dashboards. Okay, automating deployment frequency. So remember, deployment frequencies was the frequency of successful software releases to production. So we have a commit to main, and we want to deploy to production. How often can we do that? That's our question. And because we practice trunk-based development, we need an identifier of each unique change we insert into our main branches. So we know that every time this is a change, how often this happened. So this is the final result. I really like this dashboard. I know maybe it seems like numbers, but I'm super excited about it. Nerd. So I want to highlight for now the deployment frequency panel. So as you can see, we already are able to measure, and we can have the time range. So this is for the last 24 hours, but we can change these for the last 6 months. That would be amazing information, right? And also, we have TKI, which stands for 3 key identifier, and basically is identifier for every service that we have at Salpay. And this is our most recent service for Icelandic payments, but we can access the service for other teams. So other teams already started using these too. And then we have some curiosities here, like you can have the latest version that was deployed, and you can also do funny things like have the pod memory usage per version and so on, but not the focus of this talk today. Okay, how did we arrive to that panel? So this is just the PromQL query. You have a count because you want to count the number of times you deployed. You have a count without because you don't want to count the 3 different pods we have and the instance and so on. And then you have count over time because, again, we have the time range, so you can select if you want to see the last hour, the last 24 hours, the last 6 months. And then we have self-pay application build info, which is actually the metric that we are using to capture this information. And this metric is special because it's an info-style metric, and we usually use this type of metric to capture metadata. So the version of the change of the code is metadata, but so it can be the branch, the Go version that you are using, the build user, the build date. Anyways, any build information, any build metadata that you want to insert in your metric. But today, we care about the version, which is the identifier of our Unix changes. And our version is just a date in a timestamp of the date, the current date at the time. So we have our version, and this will always change. This is like dynamic information. So we are going to take advantage of LD flags in Go, and we are going to insert this dynamic information into the binary at build time without the need for source code modification. That would be crazy. So in our Docker file, we have this build argument, and we just pass it as a LD flag. This is the command to get the timestamp. So you run this after you pass the test in your CI/CD pipeline. And then you have to pass this in your code, like in your metrics. You have to pass it. So you just have a variable that will have this information, and you pass it as a label, as a tag in your metric. Finally, you run the code to initialize everything and get the information. So this is basically it. And then we have automating lead time for changes, which is pretty much the same logic, but now we don't want to know how often, but how long. For commit to man to deploy to production, how long did that take? So we will need both the timestamp of the commit and the timestamp of the app being live in production. This goes to the panel on the right, so we can obtain the average lead time. For us in our service right now, it's 10.5 minutes. I'm not bragging. Yeah, so how did we do this? Again, it's a PromQL query. It's an average time, so you use the average function. You use minim over time because, again, you want a range, and minimum because we have several pods, so we want to discount any discrepancies between that. And again, we are going to use the LD flags. But now, instead of passing the version, now we'll pass the commit timestamp, so we can use that information to calculate the lead time. This is the command to get the commit timestamp. And then in your code, you just calculate lead time. It's not that complex. You use time.since, you give the commit timestamp, and it will calculate the difference until now. And then you pass this value, this lead time, as a value to your metric, your new metric. Okay, so this was it. It's very specific to the tooling we have and the dashboard that we wanted to obtain, but the logic, whatever tool you use, is the same. Think about it as in a simple way. How often? Okay, how can I get this data? How long? Okay, how can I get the commit timestamp and the app being deployed in live? If you can get these two informations, it will be very easy for you to automate the measurement of these metrics. And finally, we are all very tired, right? So I convinced you, hopefully, that you really care about DORA metrics. I kind of gave you ideas at how to measure it, but now maybe you went home, you measure, and you're like, oh my God, I'm a low performer, what can I do? So this is the last part of our presentation, which is, how can we score well on DORA metrics? So going back to Accelerate, remember, they told us how to measure, but they also tell us what practices in the industry high-performance teams usually do. And yeah, I know it's scandalous, but it's not hiring the smartest people you know and putting them in a cave and they do code and it's amazing. So there's no magical recipe to have like these high-performance teams, and these teams actually have all kinds of engineers. They have the rock stars, they have like just the average one, they have people like me, and they are great teams because great teams make great engineers and not the other way around. So what does DORA research program tells us about these teams that are highly performant? So they tell us a lot of things, and I could not include everything in here, so I invite you to read this book and read Google's research program and so on. But one thing that I really like is that they say that great teams have a strong learning culture. And we talk a lot about embracing failure. So learning, above all, is saying to your engineers that it's okay that you don't know everything. It's okay that you don't know what your user wants. So we are going to embrace learning. Learning in a sense that you want to ship features quickly, to experiment in the market and get user feedback, and you will learn a lot by that. But also learning in the sense that you don't have to be a genius programmer, genius engineer, and you need to set aside time. So for example, in our team, we have learning days every 2 weeks where we just experiment. Learning will give your engineers the opportunity for experimentation. And experimentation is very important for innovation. They also say to work in small batches. So we have been saying, oh, we need to keep the user feedback low, the feedback loop low, we need to deliver quickly and so on. That will only be possible if you work in small batches. So if you develop these amazing complex features that takes 2 months or 3 months to release, and then in the end you find out, oops, it's not what they wanted, and it might be amazing, but it's not what they wanted. So working in small batches is very important, and these batches should be independent, testable, and valuable. So how can we work in small batches? How can we not let ourselves just have our features in a branch in there for like 1 week or more? Studies also say that practicing trunk-based development will actually help you to run away from this tendency. Of course, trunk-based development is not the only way that your team can be high performance, but it helps you a lot to escape from the tendency of developing features in branches and these branches living there for 1 week or more. I have experienced this. Practicing trunk-based development also means that probably you will be practicing pair programming. And pair programming enables you to coach and mentor your junior engineers, and also to make sure that the code you are writing is of higher quality. And you have confidence in shipping this code to production because besides having an automated suite of tests that will check for any bugs, you always have at least one senior engineer that looked over this code. And of course, in PRs, you can also have these, but everything is extended in time. First, a developer works alone, and then the PR is there waiting for someone to review it. This is much more organic. And yeah, as I was saying, if you want to do all of these, you need to have an automated suite of tests. You need practice TDD. You need to practice a lot of continuous testing. Have your CI/CD automated, and so on. And testing is also a way to get feedback. You get feedback not only by sending it to the users, but also by testing it and finding out bugs quickly. And finally, this is a Go conference, right? So actually, the studies don't say that we should use Go, but I have a very, very strong opinion that actually Go might help us, because Go is a language that has an amazing developer experience, right? And this is about delivery and about how engineers feel when they are creating things. Just quickly, to decrease the lead time, Go gives you a fast compile time and fast tests. So your lead time will be shorter and your deployment frequency will be higher. And then the tests are also easy to write, so you'll be more like, okay, let's write some tests. If it's easy, you'll write more. You will not be, okay, this is so much work, I have to use my brain so much. And we have explicit error handling, and it's tightly typed, which means that you are probably have less errors, which will decrease your change failure rate. So it's okay, it's almost finishing. Wrapping up, just for those who fall asleep in the middle, the ability to experiment cheaply and without fear is what makes great teams. And DORA metrics help you benchmark this ability. So we also learn how you can start measuring it and how can we improve if you are not a high performer or elite performer. And really the message that I want you to take home today is that high-performance teams, in terms of software delivery, we make engineers happy and empowered, and happy and empowered engineers are essential for high-performance teams. One cannot exist without the other, so you make this virtuous cycle where you have the most amazing engineers. And imagine how your organization can benefit if your engineers feel that they can build anything and they are happy. Okay, thank you.